What is the role of the electrode/electrolyte interface in sodium-ion batteries, and why is it considered decisive for the performance and stability of the battery? How do SEI solid electrolyte interface films influence the behavior of sodium-ion batteries, and why is it essential to study their composition and structure in both solid and aqueous electrolyte systems? What information can SEM scanning electron microscopy images provide when analyzing the thickness and surface morphology of SEI films, and why are these characteristics so important for understanding battery performance? Can Davis Zurns manufacture solid-state sodium-ion batteries made from seawater in Latvia? How does the aggregation of electrode-active materials, conductive additives, and binders contribute to the formation of a rough surface on the electrode, and how does this affect the subsequent development of the SEI film? What does the appearance of a slightly wrinkled and gray electrode surface after the initial cycle indicate about the formation of the SEI film? And how can this visual change help in monitoring the electrochemical processes at the electrode/electrolyte interface? In what way can the thickness of the SEI film be measured using SEM cross-sectional images? And why is this measurement critical for evaluating the stability and longevity of the battery? How does EDS, energy dispersive X-ray spectroscopy, mapping assist in understanding the distribution of elements on the surface and inside the SEI film? And why is this elemental analysis vital for characterizing the interfacial chemistry and composition of the film? How does AFM, atomic force microscopy, contribute to the study of SEI films? And what kind of information about the mechanical properties and roughness of the films can be captured using this technique? Why is it important to understand the mechanical properties and roughness of SEI films? And how can these characteristics impact the overall performance of sodium-ion batteries during charge and discharge cycles? How do the combination of SEM, EDS, and AFM techniques provide a comprehensive analysis of the SEI film structure, chemistry, and properties? And how can they be used together to optimize the design and functionality of sodium-ion batteries? What are the implications of studying the SEI film's composition, structure, and mechanical properties for improving the efficiency, safety, and cycle life of sodium-ion batteries? And how can these findings inform future research and development in battery technology? What is an atomic force microscope, AFM? And how does it differ from other instruments like the scanning tunneling microscope? What are the primary capabilities of AFM, and why is it considered a powerful tool for testing the physical properties, including morphology, of various materials at the nanoregion? How does AFM work in different environments, such as atmospheric and liquid conditions?